In a previous video, we talked about abstract accounts and how they can be used to enable smart contracts to send and pay for transactions. We also talked about cron transactions and how they use abstract accounts to send transactions as blockchain cron jobs. Now we will talk about eventual transactions. These are transactions that are triggered from blockchain events, from events emitted by a smart contract. For example, a user sends a transaction calling a function of this eventful contract. This contract emits a send transaction event, which is treated as a standard trigger for the client to programmatically send a transaction with data provided in the event arguments. The target contract address is an indexed event argument. So this transaction is processed by the EVM module, then the state change is applied to the eventful contract storage, the logs are added to the transaction receipt, and the event is detected in a post-transaction processing hook by the abstract account module. The authorization is verified and the transaction is prepared by the abstract accounts module and broadcasted. It then enters the same process as any transaction where its validity is checked first, then broadcasted to other peers, then included in a block and executed as part of the chain. The transaction execution, which is done in the EVM module, applies the state changes to this target contract that was defined in the send transaction event. Then the receipt is stored in the blockchain state. And this is the prototype demo with the eventful contract interface and the target contract interface. These are the contracts that we will use, and to make it simple to understand, we have the target contract that stores a variable that can be read with the get function and set with a set function. The eventful contract has a function that simply emits a send transaction event. Depending on whether the eventful transaction will be paid by the eventful contract or the transaction origin, this event can contain additional signatures. I deployed these two contracts, and now let's call the eventful contract function with the address of the target contract, a value of 0, a gas limit of 200,000, and a call data that will change the 0 value that we currently have in the target contract to a value of 3. And we are using the function signature for the set function in the target contract. Let's confirm the transaction. And we see the post-processing hook picking up the send transaction event. So we should expect the transaction to be processed in a later block, and then we will see this variable with the new value of 3. You have seen a mechanism for eventual transactions that is trustless, using abstract accounts. You have seen transaction automation with respect to events based on the assumption of block-level finality. This mechanism may lead to vicious transactional explosions that are hard to foresee. Keep in mind that these eventual transactions require fees, just like any other transaction, but extra care is needed when event dependencies are created. But the mechanism can also lead to virtuous, circular economies of dependent contracts.